We are going to be discussing the traveling salesman problem from Chapter 6. There's two concepts that we need to be familiar with. The first is the Hamilton path. A Hamilton path, that's a path that visits each vertex of the graph once and only once. The second concept that we need to be familiar with is a Hamilton circuit. A Hamilton circuit is a circuit that visits each vertex of the graph once and only once, and at the end of the course, the circuit must return to the starting vertex. So let's look at an application of both of these examples. First, what we're going to be looking at is a weighted graph. Over here, we have a weighted graph. If you see, this is a model of 4 different cities. Let's just call them A, B, City C, and City D. Now, if you see on each one of these edges, there is a weight. That means the distance between A and B is 200, or the distance between B and C is 140, or A and C is 210. Now what we're going to do is find a Hamilton path. Remember, a Hamilton path is a path that visits each vertex of the graph once and only once. So let's say we start at A. We start at A, and we go to another vertex. Let's say we go to C. Now the weight of A to C would be 210. From C, we could either go to B or to D, and let's go to D, which would be 160. And lastly, let's go to B, because a Hamilton path needs to visit each vertice, and that has a weight of 70. So this would be an example of a Hamilton path. You start somewhere, you go to each of the vertices, and after you've been to each of the vertices, you are done. And so the total weight of that Hamilton path would be 440. Now let's take a look at what a Hamilton circuit is. A Hamilton circuit, that starts at a vertex, goes to every single vertex, and at the end goes back to the same starting vertex. So let's use this same Hamilton path. Let's just make it a Hamilton circuit. So let's say we start at A. We start at A and then we go to C. That was 210. From C, we're going to go to D, which was 160. And from D, we're going to go to B, which was 70. Now, we've been to every vertex, but to make it a Hamilton circuit, what that Hamilton circuit says is that we have to go back to our starting vertex. So from B, we have to go back to A, and that would be 200. So the total of that would be the original 440 plus 200, which would be 640. That would be the weight of that particular Hamilton circuit. The next concept that we need to be familiar with is a mirror image. Now, sometimes what I like to do is I like to make a pictorial model of these circuits. So let's say I have A, B, C, and D. So this is A, this is B, this is C, and this is D. And if I graph, I went from A to C first. I went from C to D. After D, I went to B. And then B, I went back to A. And so it looks kind of like this: A, C, D, B, and A. A, C, D, B, and A. Now if you see, I went A, C, D, B, and A, but the same circuit, I could also do the mirror image. That is going the other way. So instead of going AC, going this way around the circuit, I'm just going to go the opposite way. I'm going to go from A to B first. I'm going to go A to B, and then from B I'm going to go to D. From D I'm going to go to C, and from C I'm going to go to A. Now this is called a mirror image. Okay, if you look here, just by looking at it, A, C, D, B, and A. It's just kind of written backwards. So every circuit has a matching mirror image. The last concept that we need to be familiar with as we move on into the different algorithms is a reference point. Reference point or starting vertex. Now every single, just how we had this circuit here, we wrote it two different ways. We wrote it two different ways because of the mirror image. We can also write it a variety of ways if we change the actual reference point, our starting vertex. So we're going to use this same circuit, but we're just going to change the starting vertex. So if you see, our first one, we started at A. Well, let's write this same circuit a different way, but let's change the reference point to B. So we're going to write it B. And now B, we could go either two ways. We could go BD or we could go BA. Let's go BD. So BD, and then we would go C. From C, we would go to A. And from A, we would go back to B. Now this would have the same weight as this one up here. This would be 640. All of these would be equal to 640. They're all the same because it's all the same circuit. It's just a different way of writing it. And we went B, D, C, A, B right here. We could do the mirror image as well. It would just be backwards of this, B, A, C, D, B. So if we went B, A, C, D, B, that would be the mirror image. And it would have the same weight, total weight of 640. Let's go ahead and write it again, but let's have it start at C. So if we have it start at C, we can either go CD or we can go CA. Let's go CD. C, D, B, A, and then back to C. That would just be writing the same circuit, but changing the reference point to C. If we wrote the mirror image, it would just be simply backwards. C, A, B, D, C. It would just be going the other way. C, A, B, D, C. C, A, B, C, A, B, D, C. And lastly, if we did the same thing but we changed the reference point to D, we would have a similar thing. It would just be D. Well, we could either go DC or DB. Let's go DB. D, B, A, C, D, or the mirror image would just be backwards. D, C, A, B, D. And if you can see, there's a lot of different ways to just write the same circuit using mirror images and changing the reference point.